Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an allylic or homoallylic alkyl halide is treated with water in the presence of a mild base, CaCO3, which neutralizes HCl as it forms, the reaction can proceed via neighboring group participation or carbocation rearrangement. Here, Me to C is equal to CH, CH2, CH2, Cl is a delta epsilon unsaturated alkyl chloride. The double bond is separated from the leaving group by 2 carbons. Step 1. Identify the substrate. Me to C is equal to CH, CH2, CH2, Cl. The chloride is on carbon 1, counting from Cl, and the double bond is between C3 and C4, i.e., C3 is equal to C4 where C4 bears 2 methyl groups. This is a 4-pentenyl type system, homoallylic chloride with 1 extra CH2. Step 2. Ionization and neighboring group participation under aqueous conditions with CaCO3, mild base, SN1 favoring the CCl bond ionize. The developing carbocation at C1, primary, is unstable. The remote pi bond, C3 is equal to C4, can participate through intramolecular electrophilic cyclization. The electrons of the double bond attack the carbocation center, C1, forming a cyclopropylcarbonyl type intermediate or directly a cyclopropane ring via pi participation. Step 3. Cyclopropane formation. The pi electrons of Me to C is equal to CH attack the primary carbocation at C1 forming a 3-membered ring, cyclopropane. This places the positive charge on the tertiary carbon, Me2+, which is then captured by water or OH to give a tertiary alcohol, cyclopropane ring with a Me2OH group attached. This is the product shown in option D1, 2-hydroxypropan, 2-vial, cyclopropane with an OH on the Me2 group. Step 4. Why other options fail? B. Me to C is equal to CH, CH2, CH2, or is the simple SN2 substitution product, direct displacement. This is disfavored because I. The carbon-bearing Cl is primary but the reaction uses aqueous SN1 conditions, and 2. Intramolecular pi participation is much faster giving the cyclopropane. A. Involves a rearranged tertiary alcohol without ring formation. The mechanism does not support a simple 1,2 shift to give that product. C. Involves hydroxylation at an internal carbon, which is not consistent with either SN1 or SN2 on the terminal carbon. Step 5. The major product is the cyclopropane ring bearing a Me2OH group, option D, formed via intramolecular pi participation of the alkene onto the primary carbocation, followed by trapping of the resulting tertiary carbocation by water. Therefore, the correct answer is D. Therefore, the correct answer is option D.